Hello and welcome to this episode about color space, and I say thank you for joining in because I think some people will have skipped this, and this is of course very sad because any part of the whole pipeline that is not really understood is of course a black little spot in the whole pipeline, and it will drag you down. And so thanks for joining. Color space, that is something that is not that simple because we have two areas, and I will describe this here: physical and perception. And exactly this split here makes it so hard finally to discuss those things, because our perception is the only thing that we finally have, and we can say the physical part or the physical quantities in the whole mix is something that we can express in diagrams, in numbers, in formulas of course, but it always boils down that we want to see it, and many description of this area are based on things that we can't see. They just assume that it is in this way, and I will show you that in a second. So with these two things in mind, I put this here away. We have of course a longer story here to tell. The main part where we are interested in is of course that we get from our camera exactly then finally everything in the way we want to have it in Cinema 4D. That's the way we want to have it, exactly. So the camera by itself can work in one color space, and we want to have the same color space in Cinema 4D. And I would say 20 years ago or so, when I started with Photoshop, for example, I thought that R, G and B is just everything, and when I put some values in, someone else gets exactly the same numbers and it should look like the same. That's of course R prime, G prime, B prime as we know it, because the numbers by itself will stay the same, but when we have these little things here, then it is the perception of it, and that will vary because we have all the time here just a monitor or a screen, whatever, to see what we have. That can be also a printout, and that has then finally to deal with the devices that we use. Different screens, different devices in terms of projectors, printers and so on, creates exactly a different perception for us. They display these things not exactly like numbers, and so we have a problem here. When we have here, for example, a nice color, and I do not name any color here, we have one nice color in mind, we photograph this and we want to see it of course on our monitor, and inside of Cinema 4D we want to use it in the same way. So Cinema 4D is of course mostly, or should be in these years, linear, and inside of cinema it has worked always linear, because with the gamma curve up and down to get the same idea, that was only for the monitor area all the time available, but normally the data needs to be linearized. The monitor by itself has of course a gamma curve in it, and when you listen to some explanations of this area, they say, yeah, the old tubes, they had of course a characteristic like this, so we had to build our images like this to get finally a perception that our eyes has. That's only half the story, and it's not directly correct, because we did not move along because the screens couldn't work in that way. Our perception is always that we find in the average a very specific point, a gray point, and this gray point then has our main interest and we adapt to it. And the funny thing was that the screens at that time had pretty much the same characteristic in reproducing these pictures. It goes even further. The lucky success of the whole system was that we are more interested in tones below the 50% gray or 0.8 gray than everything above that. And our perception is of course that we look more horizontally than all the time in the sky, and that's my personal view of that. So we try to get here out of these few values a lot of values when we go with a curve diagram. And here the curve gets flat. That means we get from a lot of values that goes in only few out. And that balance exactly our perception. And all of that found finally during the time when we had only 8-bit and limited amounts in the graphic cards, everything a nice balance. And so we stick with it. And even today, when we could have linearized screens, we stay with it, because when we want to have web-based stuff, the 8-bit and gamma idea is not really dead. But for everything that we want to have in high fidelity, so to say, we want to have everything linear. And we have to work, of course, with older formats that have a gamma in it, and we want to output stuff that has perhaps a gamma in it when we print or so. Anyway, long story short, all of that is of course based with not only gamma, it is also based on color values, RGB. And what the camera can see is something else that the monitor or the screen can produce, and so on. So we had to find here an area that gives us something like a translation. Like we have some coins in the pocket and we go to a different country. We want to have a translation so we get what we want. And in each country we get maybe a little bit something different, and each time we have a little loss. And this is a simplification, of course. I want to show you some of the roots of it based on a little bit more than just a few graphs here. And again, I simplify here. If you like so, Charles Poynton, Digital Video and HD, and please use the second edition. It's a big book and it explains everything. So what I want to do here is, of course, to give you an extract from what I have learned from him. I had also some direct courses at FX PhD with him, 2 of them to be precise, and in conjunction with the book you get really a huge overview in this whole area. And he writes, for example, papers for SEMTE and all of that, something that you have maybe all the time on your screen. And so let's have a look to some of these examples. I start here in the ColorSync utility from Apple, and I think there's something similar available for Windows, but it's not directly on this system if I got the information correctly. So I start here with this cube, and I have something in mind with this cube here. You can see here already we have here a white point and we have here a black point. And when you look carefully, this is a green axis here, this is a red axis, and this is a blue axis. And this is relatively to the tree stimulus or tri-stimulus, and this has to do with our eyes. And the whole idea here of the generic X, Y, and Z profile is to represent finally what we can see. And this is of course something that is done scientifically, and I think it roots has it from 1920 and it's pretty much a color space that can contain everything. It's huge. So any value that you have inside of this cube based on the 3 axes, and you are more or less familiar with those things in Cinema 4D, any axis represents now one color, and you can place in this space one spot and it can be defined exactly. So is it helping us at all? No, not really, because we go here beyond anything that is displayable on our screen. And these colors here are not really colors that this screen or your screen can show. It's what our eyes can see, and that is beyond of what the most screens can show. Of course, there are screens available and they are in the 5-digit range that can do that. But normally a laptop or a desktop is not able to do that. So what we have here is of course a black point and a white point. And the white point is not really here only, we have it also in this area here. And I will explain this in a second. First of all, we can say that when I go here back to this area, the bluish looks a little bit darker than the reddish, and the reddish area looks a little bit darker than the greenish, and that has to do with our perception. And so you might think, wow, that maybe explains it why we have in bion pattern in our cameras here 2 of these green guys, 1 of the red and 1 of the blue, to mix finally our perception in a better way. And I think that is the reason. Someone might correct me and has a different theory in that, but roughly that sums it up to make it clear. So the more we go now from the black area here to the white area here, we go through a space of saturation. And saturation is of course nothing that we can really measure. We can only say some numbers. The more distance between some of these axes, the more saturation we have. And when we go to the white or to the black area, we have the least perceptual saturation. It's not all that simple, and I try really to go here very fast through something where I think other people have used at least 10 hours to explain it. Anyway, so we have here a nice cube, and we can say inside of that cube we have every color that you can produce in Cinema 4D. Period. And that gives us, of course, then an option to say when a color in this area here is very fixated, when we can agree to something like that, then we can also say when we have this space, then we want to have a connection to our monitor, we want to have a connection to our scene in Cinema 4D. And we can say when we put now one of these values in this pipeline here, we get this or another color on this monitor. And so we can swap out monitors and we get different calculations then here in the pipeline. The calibration, for example, gives something like this, and we will, if the monitor is good enough, see the same color in different spaces. So we have some certainty in it. But as I said, here are colors that are not reproducible inside of this pipeline here. So before I go a little bit deeper into that, I want to show you now exactly what the black and the white spot here means. And I go for that into the generic gray profile. And you might have problems to see that after the compression, but here are black and gray points. And when I put them all in one line, you can see there is a line very straight. And it doesn't go from this point here, 0, 0, 0, that's clear, that's completely black, then to the white point, whatever the white point is. It's a longer discussion, it's not that simple finally. But it ends here somewhere, and when I move this, it's maybe more visible. And as I said, the blue has not so much power, but red and green mixed together to yellow, or with a little bit blue, generates already white way before we reach this point here. So we don't need all values in this color space 200% to get something that is white. And again, white could be a lot of things, and the discussion is not on its end where is really the white point. We can't say with some certainty where the gray point is. Somewhere here on this line. That's pretty clear. And so black with absolute 0, we have always black values that are a little bit above, because there's noise in it and we want to tweak those values. Something that is 0 already, we can't multiply it with anything because it stays 0. So we need a little bit more here. So black could be here in this area, but the gray point is the only stable value that we can think of. Or 0.18, or in the old world 50% gray when we think about gamma. Okay, so now we have here a line. And you remember maybe when you were sitting on your editing suite or your color grading suite, you had something that looked maybe a little bit more like this. 6 edges, and then here this white point more or less in the middle. Something like this. Black and white, not really clear, but in the middle. And that has to do here when we go now to the RGB values. Adobe RGB is one of the wider color spaces, and based on the values that we can produce with this, we get then a cube like this. And you see this point here is now exactly where the cube ends, and the black point is here. I go back and forth, gray, you see here this point, and I go back to RGB here, Adobe RGB, a very big difference to sRGB. As you can see, it's a little bit smaller here. So we are used to think in terms of luminance because our eyes produce a much better definition of values in terms of brightness than in terms of color. And so typically we rotate this cube here now that the black and the white area is on top of each other, and we have then only to deal with the color. And for that I can go here to this area and I can switch now here to lab mode. And then you can see something happens here. The cube by itself is now completely distorted, but the black and the white area, the gray line to be more precise, is now on top of each other. And so when we take a look, you might notice a similarity that you have seen with the horseshoe diagram. And let's have a look how that looks like. That's exactly this one here. And when I look from the top and I rotate this a little bit, then I can have exactly this view. And you remember perhaps a triangle here inside, which is then the sRGB. Very small and here a little bit distorted because I should move that. This is a three-dimensional representation of that. And this curve here is of course also very defined in the whole space. Normally we have the big Y, the luminance, now exactly in our axis. That's exactly in our view axis. And the small version then exactly here as a diagram. And when we think about all of that, we can say that this line here is y equals 1 subtracted by x. That means the bigger the x gets, the smaller the y gets, and so on. So this is a 45-degree line here, just like that. And this describes here this area here. Beyond this, we don't have any values. The spectral locus is exactly here, this line, this horseshoe, finally. And the line here beneath that is a line that goes from the 400 something to 508, 510, 515 nanometers to 700 something to this one here. So red and this blue area is normally split apart, but when you mix these two values, and nanometers are exactly the way we describe visible light, then we get here our purple line. And inside of this we have normally a curve, and this is the black body locus, which we use normally to move things around based on our white balance. And black body means here that when a body is completely black and it is not heated, then it is black, and the more heat it becomes, the more it starts to glow. And it starts from the red and it goes then to blue and white. You might remember that when you see flames, very hot flames, they are more bluish. And then somewhere here is of course the white point, and that's a big discussion. This is a Cmyk chart finally, and it helps us to define the gamut of the whole area, just to give you a little info into that. So what I will do here is I go back to my lab mode, where I can have exactly now my cubes a little bit distorted based on the color space. So what we have discussed here so far was of course that inside of these spaces we have values based on, and you can see here, blue, red and green again, and I rotate this maybe in this way here. Then we can say inside of this cube we have now all colors available that sRGB gives us, and S stands normally for standard. This is the smallest agreement between all of these color spaces, and this gives us of course the option to finally go beyond what we normally have in terms of stability. And stability means here only that we get inside of our pipeline here, if color managed correctly, always the same idea what the color was that was described inside of this cube. So anything beyond this cube here will be not represented. sRGB, again, standard red, green and blue, the smallest agreement between all the things happen. And we have here, of course, also all the web standards in it. Everything that is web safe is a little dot here inside. What we want to have is, of course, that this space is as large as our camera, for example. And we can, in some cameras, change this. Srgb is maybe the standard for point-and-shoot cameras. But if you have a camera that has a little bit more professionalism in it, then you have maybe the option to choose from sRGB to Adobe RGB. And this is, of course, something that we will discuss in the next part. And then all these values here have a better definition because the space is larger. And this should be then, of course, always at least 16-bit per channel. Otherwise, you might lose something. And the whole agreement here is, of course, then all over the place. And if done wisely, you get results that are reliable. And it's not just, oh, I hope it gets, and let's put a curve over that. It looks a little bit weird. We want to have something that is stable. That is maybe my target here for this course. And of course, we want to have something where we have agreed to. We can go here, of course, shortly to Cmyk to see how much color is left when we print this out. Here again, we can see the gray values go just straight. The gray profile, one time with gamma, one time without, and you see how these points move here. Then the lab profile, again, that's in more or less artificial space because it's beyond what we can show. RGB. And here the huge file where we started from, the huge cube that has all colors in it that we can perceive. And to give you another little helper here to imagine what we finally have here, sRGB, and now have a look here to Rec 709, which is the HD color space. It's pretty similar. It has only a few little changes in it, and I don't want to discuss here this because that is more for the color profile. And when you go with cinema color, we go then more into this area here, which is a little bit larger. Of course, the way we work maybe later in ACES is more like this here, and this is the output then also DCI, P3, RGB, gamma, and we can have tons of other ones. Check this out, it's really interesting to play with, and you can see and you can compare even these values. So that's in a nutshell, of course, everything about color space. And we have seen here already some profiles, and I want to give you, of course, a little bit more practical about the color profiles in the next part. See you there. Thanks for listening. Have fun with it. Bye bye.